My name is Professor Collins, and this is your daily dose of statistics. So today we are going to continue our talk on inferential statistics, and specifically we'll be talking about an independent sample t-test, and we'll be going into detail about that. And so again, we're still on our road of hypothesis testing, and we've talked about just an intro to hypothesis testing, the one sample case, the paired sample case, and now we were talking about the independent samples case. And so we'll discuss that here today. So let's first take a look at using the independent samples test of significance and what that means and what the purpose of that is. So what it does is it compares two independent groups' means on some outcome. So let's call that variable x. This is often used for experimental studies. For example, we could look at control group versus experimental group, for example. And this is often done in, say, drug trials, right, where you're putting two people into two separate groups. It's more frequently, however, used to look at means for different natural groups, right? Men versus women, Asian Americans versus African Americans, STEM students versus social science students, right? So it's oftentimes more used to look at naturalistic groups instead of your sort of typical control versus experimental group. Now let's take a look at our running example here. So for example, today we're going to use the Stanford Prison Experiment. And so let's say we have this research question. Is there a difference between white prisoners and prisoners of color in the frequency of abuse interactions between prisoners and guards in the Stanford Prison Experiment? And our outcome measure here is simply counts of abusive interactions for each prisoner. And so let's take a quick video and just check out the Stanford Prison Experiment and what that's all about.
In the early 1970s, an experiment on the psychology of imprisonment was carried out at Stanford University by psychologist Philip Zimbardo and his colleagues, who created their own jail at the basement of the Stanford Psychology Building. The students who volunteered for the study were carefully tested. Each had to be psychologically and physically healthy to participate. Some students were then randomly selected to act as prisoners, while others became guards. The researchers surprised the prisoners by having them arrested at their homes and dormitories. The prisoners went a series of rituals to establish their new lowly status. They lived in tiny cells 24 hours a day, cut off from their usual surroundings.
What is happening to prisoner 819? Prisoner 819 is being punished, Mr. Correctional Officer. But your response on history, remember. Prisoner 819 is being punished, Mr. Correctional Officer. Down. Up.
The guards, however, only worked 8-hour shifts, and they returned to their normal routines as students when off the job.
Up. 5 right 6 is our belly goal. Push up. Keep that back straight. Down.
What happened surprised everyone, including Zimbardo. The illusion became the reality. The boundary between the role each person was playing and his real personal identity was erased. Nice boys became brutal guards. Healthy kids got sick. Active ones became passive and zombie-like prisoners. The situation became so overpowering that many of the prisoners developed extreme stress reactions and had to be released. But no one ever said, I quit the experiment. They had lost all perspective.
You come over there. to walk over here like Frankenstein and say that you love children and see.
What kind of guard would you be? Sadistic or supportive? Would you be a conforming prisoner or a heroic resistor? The prison study, like Milgram's experiment, is not typical of research in social psychology. Some psychologists feel both studies violated ethical guidelines that should never have been done.
2, 3, 4, 5, 6, 7, 8, 9, 10. Now you go over there and tell my boys that you love me. I love you. Ain't that sweet? Ain't that sweet?
At times, even Zimbardo forgot he was an experimenter and acted like a prison warden. Though the experiment was meant to last 2 weeks, it was called off after 6 days.
Once you put a uniform on and are given a role, a job, saying your job is to keep these people in line, then you're certainly not the same person as if you're in street clothes and in a different role. You really become that person once you put on that khaki uniform, you put on the glasses, you take the nightstick, and you act the part. That's your costume, and you have to act accordingly when you put it on. It still is a prison to me. I don't look on it as an experiment or a simulation. It's just a prison that was run by psychologists instead of run by the state. I began to feel that identity, the person that I was, that had decided to go to prison, was distant from me, was remote, until finally I wasn't that. I was 416. I was really my number, and 416 was going to have to decide what to do. It let me in on some knowledge that I've never experienced firsthand. I've read about it. I've read a lot about it. But I've never experienced it firsthand. I've never seen someone turn that way. And I know you're a nice guy. You know? You understand? I do. I do know you're a nice guy. I don't get that because I know what you can turn into. I know what you're willing to do. If you say, oh, well, I'm not going to hurt anybody. Oh, well, it's a limited situation. It's over in 2 weeks. Well, you in position, what would you have done?
I don't know.
So that is one of the famous experiments by Philip Zimbardo, the Stanford Prison Experiment. And this can give us some insight potentially into the behavior of guards and prisoners. And so one of the questions that this may raise, right, so this brings us to our research question again, do guards potentially treat prisoners differently depending on their race, right? Maybe they treat prisoners of color differently than they treat white prisoners. So this is a question we can test, right? And so let's say that Zimbardo counted up the number of abusive treatments that guards gave various prisoners throughout the 6 days of the experiment, and calculated the averages here. And so let's say we have the averages and the standard deviations for both groups. So on average, prisoners of color were abused 32.56 times over 6 days, with a standard deviation of 2.45, and there were 17 of them. White prisoners, on the other hand, were abused on an average of 31 times over the 6 days, with a standard deviation of 2.34, and there was 20 of them. Right, so we can ask this question statistically now, based on this information. And so let's just talk about generalizability for a bit. So what we're doing here is we're taking a population of prisoners of color, right? And so this is an experiment done in school. So this is not as naturalistic as could potentially be done. But what we're doing is we're taking population of prisoners of color, for example, and we're taking a sample of them. And so we're extracting the sample of prisoners of color from the overall population of prisoners of color. So in this case, in the Stanford Prison Experiment, we can maybe say people of color instead. And then we're taking a population of white prisoners and doing the same thing, right? We're extracting a sample from those, and what we're doing now is we're going to compare the two means across these two groups. So this is where independent samples come in, right? So we're generalizing back to the population but we're also comparing means across the samples, and what we're doing is we're using those means and comparing those means to infer to the population. So the inference would be that if this pattern is different across these two groups, if one group is abused more by guards than the other group, then we can infer that that may occur in the general population as well, particularly for prisoners, right? And so let's go through our 5-step model of calculating T. So the first couple are going to be like you've seen before. And so step one, of course, we're making assumptions. Again, sampling is random, sampling distribution is normal, and our outcome measure here, which is number of times abused, is interval ratio. Right? So you've seen this several times, and this is going to be the same for all the t-tests. Then we need to state our null and research hypotheses. So again, let's go back to our research question. Is there a difference between white prisoners and prisoners of color and the frequency of abuse interactions between prisoners and guards in the Stanford prison experiment? So our null hypothesis here would be something to the effect of white prisoners and prisoners of color do not have a difference in the frequency of abuse. And so it's represented by this notation here, where we have the mean of white prisoners equals the mean of prisoners of color. Right? So what we're saying is they're the same. Their means are the same. Our research hypothesis, on the other hand, is going to be slightly different. It's going to be actually the exact opposite of the null hypothesis. And we would state something to the effect of white prisoners and prisoners of color are different in the frequency of abusive interactions. And it would be represented by the notation here, where the mean of white prisoners does not equal the mean of prisoners of color. Right? They're different. And so we're going to test that statistically. So now we have to move on to step 3. So we have to select our critical region and our 1- or 2-tailed test. And so again, let's go back to our research question. Is there a difference between white prisoners and prisoners of color? And so this is important, right? Because now the last few lectures we've talked about a directional inference. This time we're not. We're just simply looking at a difference, right? We're asking the question, is there a difference? But we're not stating a direction. And because we're not stating a direction, we're looking at either side of the distribution. So we're looking for a 2-tailed test. And as with the other t-tests, we need degrees of freedom. So let's just quickly refresh on that. Remember, the t-distribution varies by sample size, right? So for sample sizes less than 120, the t-distribution follows something slightly different compared to the z-distribution. So again, it's a little flatter, right? And so for the independent sample t-test, the calculation of degrees of freedom is slightly different. So what we do here is we take the n of group 1, so in this case white prisoners, minus 1, plus the n of group 2, prisoners of color, minus 1, right? So, or another way to put this is n of group 1 plus n of group 1 minus 2, right? It's the same sort of it's the same calculation. And so what we have here, what we find is when we put this calculation together, we have our degrees of freedom of 35, right? A DF of 35. And as with the paired sample test, we can use this to go into our t-table and identify our critical region, right? So again, because we're looking at 2 tails this time, we're using the bottom row. So we're looking at the proportion and 2 tails combined, not just 1 tail. And we can identify our degrees of freedom, go all the way down to the bottom. And so it starts skipping after 30, right? So instead of having specifically 35, we'll be more conservative with it and we'll go to 40. And so what we see here is that we have our, we'll round up and we'll go to 40. So you want to round up in these cases. So we have our critical region of 2.021. That's what we come up with this information. And so now what we can do is we can plot that onto our 2-tailed test. So what we're looking for now is we're looking for an obtained t-score that's either greater than 2.021 or less than negative 2.021. So they have to fall beyond that critical region. They have to the number has to fall within the shaded region, right? And so now let's move on to actually computing the test statistic. Now this one's going to take a bit because there's quite a few calculations with this. So again, what we're doing is we're looking at prisoners of color versus white prisoners. And we're looking to see if there's a statistically significant difference between them using an independent sample t-test. So let's take a look at the equation here. So an independent samples t-test equation, what this is telling us is we're taking the mean of group 1 and minusing that from the mean of group 2 and dividing that by the standard error. And this basic calculation is the easiest. The standard error is what's difficult to calculate. So let's take a second and go into that. So we'll go through each step of calculating standard error and observed t. What I've done here is on the bottom, I've color-coded the table, right? So we have mean, standard deviation, and sample size all color-coded, and those colors will go into the equation as we go through. Looking at this equation now, what you can see is, so I'll just walk through each of these. So we have n minus 1, so the sample size of group 1 minus 1, times its standard deviation squared. The n of group 2, or sample size of group 2 minus 1, times its standard deviation squared. And then the bottom of the left side of this equation here, the denominator is the degrees of freedom, group 1 plus group 2 minus 2. On the right side, we have the sample size of group 1 plus group 2 in the numerator, and then sample size of group 1 times group 2 in the denominator, and that's all square rooted. So what we'll do is we'll just plug in all of the numbers here. So I've gone through and plugged in all the various numbers, and again, these are color-coded in the table below, so take a look at that. And so what we'll do is we'll just begin solving here. So I've go ahead and solved some of the smaller equations. So I've taken the square roots, or I've squared the two standard deviations, and I've added and times everything on the right side and did the same at the bottom of the left side. And so all that will shrink up into this equation here, the square root of 199.88 over 35 times the square root of 0.11. Put those together, so now we have the square root of 5.71 times the square root of 0.11, and what we get here is 0.79. Now we'll use this equation, so we're not done quite yet, so we'll use this equation in the t-test, in the observed t equation. And so we'll bring this right up here to calculate our observed t, and you'll see where that is. So remember, our equation is the mean of group 1 minus the mean of group 2 all over that standard error, and that's what our standard error was. So we brought that up here. And we can work out this calculation here, and what we find is an obtained t of negative 0.289. And so what does that actually tell us? So what we can do is we can use this to plug into our distribution table, right? So again, we're looking at our obtained t of negative 2.089, and we're asking the question, does this fall beyond the critical region? And because this is a two-tailed test, it can go either way. It can either go on the positive side or in the negative side. And what we see here is that it's on the negative side. And so here's our obtained t. So what we find is that we're significant, but we're just barely made it. We just barely made it. So, but that's okay. We still made it, right? We're still within that 5% confidence rate, or I should say the 95% confidence rate. So now we can take that information after we compute our test statistic, and we can go on and make a decision and interpret the results. And so again, let's get back to our research question. Is there a difference between white prisoners and prisoners of color in the frequency of abuse interactions between prisoners and guards in the Stanford prison experiment? And so as you see here, we have our prisoner of color versus our white prisoners, and we have our data here. And what we find is that they are not equal, right? So there is actually a difference between the two. That's what our data tells us. And so we can check out our null hypothesis, and what our null hypothesis says is that white prisoners and prisoners of color do not have a difference in the frequency of abuse. our hypothesis is that white prisoners and prisoners of color do have differences in the frequency of abuse. And so what we can do is we can reject our null hypothesis, right? Because our critical region fell beyond our obtained T, excuse me, fell beyond our critical region. So we can reject the null hypothesis. And so what does this mean? Let's do an interpretation here. And so again, as usual, I put in blue some of the important pieces and in red the data here. So our interpretation would be something to the effect of, an independent samples t-test revealed that prisoners of color and white prisoners tend to receive differing frequencies of abuse among guards, with prisoners of color receiving more abuse compared to their white counterparts. Right? And so the difference here is that I'm not stating the direction right off the bat. What I'm doing is I'm saying we hypothesized just a difference, and then our test showed us the direction of that difference, right? So we just add the information here that prisoners of color received more abuse than their white counterparts. So that is walking through this process of doing an independent samples t-test. And so again, this is used to compare two groups. So if we need to compare two groups on some mean of some interval ratio outcome, this is what we would use, an independent samples t-test. So again, we'll continue through hypothesis testing. We have a couple more here in hypothesis testing. And after those two, we'll move on and we'll be done with inferential statistics and move on to bivariate statistics. So that is your daily dose of statistics.